This is your Chapter 3, Section 2 Math Review lesson. Today we're going to cover page 83, numbers 11 through 14, and then on page 85, numbers 20 and 21, you will be asked to solve those on your own and provide an answer. In this chapter, we're talking about the first and second law of motion by Newton, and we're going to be using the idea that force is equal to mass times acceleration. So force is in newtons. Force is equal to mass, which is kilograms, times the acceleration, which is meters per second squared. So if we're talking about a newton, what is a newton equal to? We've said this several times. If this is in kilograms, the mass is in kilograms, and the acceleration is in meters per second squared, what is a newton equal to in units? It's kilogram meters per second squared. So you can break it down that way as well. So number 11, if a helicopter's mass, you have to follow along in your book, obviously, page 83, if a helicopter's mass is 4,500 kilograms and the net force on it is 1,800 newtons upward, what is its acceleration? So we know we're trying to find acceleration. So acceleration is what we need to find. We use our triangle here. We know that acceleration is equal to the force divided by the mass. The force divided by the mass. We go back, we read it again, and the force is 18,000 newtons upward. And so putting that in, 18,000 newtons going up divided by the mass, which is 4,500 kilograms. Well, how's that going to turn into meters per second squared? Remember, what is a newton? This newton is equal to a kilogram meters per second squared. That allows the kilograms to cancel out. So whenever we take 18,000 divided by 4,500, calculator says that this is going to be 4.0 meters per second squared. Because it gave us a direction, we're going to say that this is upward. Pardon me. So that was number 11. Number 12. You need to read in your book. Number 12 on page 83. What is the net force on a dragster, or assuming that's a drag race car, with a mass of 900 kilograms if its acceleration is 32.0 meters per second squared west? So we want to find the force because it reads, what is the net force? Again, excuse me. What is force? Okay, so if we go back up to our formula, force is equal to mass times the acceleration. So what is the mass? The mass was 900 kilograms, and the acceleration was 32.0 meters per second squared west. So then we take the calculator, 900 times 32, we punch it into the calculator, and we will end up with, I believe it's 28,800. Now this is kilogram meters per second squared, which is the same thing as a newton. So that's how much force it had to be putting into it, and it was in the direction towards the west. Pardon me. So number 13. Reading in the book, a car pulled by a tow truck has an acceleration, pardon me again, of 2.0 meters per second squared east. What is the mass of the car? So we know we need to find mass of the car if the net force on the car is 3,000 newtons east. So we know we need to find the mass. The mass is what we're trying to find. Mass, if we cover up mass in our triangle, we know that mass is equal to the force divided by the acceleration. We then go back, read the question again. The truck has an acceleration of 2 meters per second squared east, so that is going to go on the bottom, 2.0 meters per second squared east. and it has a net force of 3,000 newtons east. So 3,000 newtons east. And so the east is going to cancel. The newtons, remember the newtons is kilograms meters per second squared. That's what this is. So the meters per second squared cancels. That's going to give us the kilograms because mass is going to be in kilograms. So the mass is equal to, what is 3,000 divided by 2? 1,500 kilograms. Number 14. We read the problem. It says it's a challenge problem. What is the net force? So we know we're trying to find the force. That is our question. We know that force is equal to mass times the acceleration. What is the net force on a skydiver falling with a constant velocity? It has a constant velocity of 10 meters per second downward. Well, wait a minute. For it to be acceleration, the acceleration here is 0. It has a constant velocity then, right? I don't care how heavy this skydiver is. If they are only falling at 10 meters per second downward, it's a constant velocity. There's 0 acceleration. This could be infinite. It doesn't matter. Anything, okay, anything, any x times 0 is still going to be 0. So what that means is that this skydiver has achieved what we call a terminal velocity, probably due to air resistance. He's probably gotten his parachute open. Well, I don't know much about that skydiving and how fast you would be falling, but before you open your parachute versus after. So there's question number 14. These set you up to turn to page 85. Number 20. Calculate acceleration. A student pushes a 5 kilogram box with a force of 20 newtons forward. The force of the sliding box is 10 newtons backwards. What is the acceleration of the box? So we have this box. It's a pretty large box. So we have this student who is pushing this with a force of 20 newtons. This friction, the friction here is going to oppose that with 10 newtons. We want to know, so we got newtons, right? We have this 5 kilogram box. You want to find acceleration. So you need to figure out what is the unbalanced force on this 5 kilogram box so you can calculate the acceleration. Number 21. You push yourself on a skateboard with a force of 30 newtons east and accelerate 0.5 meters per second squared east. Find the mass of the skateboard if your mass is 58 kilograms. So, let's find our total mass then. So we're trying to find mass, okay? Mass, the total mass. So what's going to happen is this. You've got yourself on a skateboard. Somehow you're supposed to be on that skateboard. You're going to push with a force of 30 newtons. We're assuming there's no friction here. The rolling friction is negligible. And you're going to accelerate this direction at 0.5 meters per second squared east. Okay? So you're pushing it you're going to go that way. So mass is equal to, if we cover up mass, is equal to force divided by the acceleration. So your force divided by this will give you your total mass. You know your mass is 58 kilograms. You subtract this amount of kilograms from the total mass, which would give you then the mass of the skateboard. So that's what you're looking for.